Okay, well, good morning, everyone. Thank you for joining with us today. My name is Rav, and I'll be your presenter for the first little while here. I'll be co-hosting this presentation with Curtis Steele, who will take on from me some halfway down the presentation and present the application. So let's just get started with it. For TRS Systems, we're in the business of simplifying IoT integration for our customers. Now, we'll get into a little bit of detail about what exactly does IoT integration mean, but let me just give a little bit of background about myself. Um, I, my name is Bravneet Singh. I go by Rav. I'm originally a mechanical engineer. I've got a master's in electromechanical engineering and an extensive fluid power background, basically. Of work before I founded my own company. I worked for some leading motion control OEMs and system integrators, and I've helped various OEMs to design and launch their control system for either their new application or if they're trying to launch a relaunch an existing platform or revamp the existing platform. Besides my own company, I'm also a resident subject matter expert at Olds College in Alberta, where I teach machine learning and embedded systems. And I'm also in charge of their research and academic integration with technologies like machine learning, embedded systems, and cloud integration. So let's just get to the presentation. So a little bit of history about TRS Systems. TRS Systems is a division of TRS Design Inc. It was founded in the year 2013 with the intention of providing machine control design. It originally started off by designing wiring harnesses and CAD design for various OEMs around Western Canada. But our current focus is we specialize in providing custom control system solutions and cloud-based solutions or cloud-based integrations for IoT and IIoT or Industrial 4.0 integration. We're very proud to be CodeSys System Partners here in Canada. With that, let's just take I've got a little video, that kind of goes into background of what is it we do and as a system integrator and how can we help our customers. So I just need a little bit of confirmation if you guys can hear the volume on the video. So Chris, if you can just let me know.
Are you a custom equipment manufacturer looking to
a little bit louder, but it's okay.
Monitoring to your equipment? Or does your equipment use Canvas or J1939-based control system that could benefit from cloud-enabled remote monitoring and predictive maintenance? If yes, then we have got you covered. At TRS Systems, we understand that your business is different. And to collect the right data and turn it into profit, you need IoT solutions tailored to your business model. With our custom IoT cloud solutions, we can provide you with a dedicated cloud platform for your unique IoT needs and help your business achieve digital transformation. We can help you achieve one or all the IoT use cases that apply to your business. So whether you're a custom equipment manufacturer, a systems integrator, or your business relies on parts or maintenance of an industrial plant, we've got your IoT digital transformation covered. Contact us today to launch your business into cloud. Stay tuned to find out about our comprehensive 4-step IoT digital transformation process.
All right, so I'm just gonna go by and just explain a little bit about our background or what kind of services do we offer to our customers. So the first and foremost is our bread and butter. We offer advanced cloud-based system integration advanced control system integration for our customers. We offer IIoT or Industry 4.0 integration under two different type of services. So the first one would be a ready to deploy EMERCLOUD which is our software as a service platform, which we'll get to see an application of here later today. And the second service we provide is a custom cloud platform, which is a cloud integration, which is completely specific to your use case. It even uses your brand name. You know, if you work for a company called XYZ Manufacturing, then the cloud is actually an XYZ.cloud in that case. We offer CodeSys v2.3 to 2.5 conversions as part of our service as well. And like I said before, we first started by designing in CAD design. So one of our services is control system design and wiring harness design, and of course, programming as well. We also provide, in partnership with Olds College, we provide basic and advanced training on IEC 61131-3 based programming interfaces. And as a medium of instruction, we use CodeSys for that, CodeSys v3.5 for that. We also offer hydraulic and electro-hydraulic control systems that are very focused on a different type of hydraulic applications. So your power units, your advanced controls of mobile valves is also something we offer. As for our partners, we have partnered with some leading equipment providers to kind of get us fast track for our prototyping stages, and also provide our customers with advanced level of support. So we are, from a hardware standpoint, we are partners with Topcon for their Opus line of displays, right from the 4.3 inch to all the way to 12-inch displays. And we've got access to them, and we can actively use them in any application. We're also system integration partners with IFM, where we've got complete access to their PLC lines, their display, even their mobile cameras that are Ethernet cameras. We have some applications under our belt that utilize the camera functionality back on the CodeSys to do some advanced controls of our equipment, especially in the ag side. We're also system integrator partners with Trombetta, where we provide the Trombetta's manufacturer of smaller CAN bus and vehicle electrification components. So stuff like CAN splitters, CAN joiners, CAN-based I/O, some vehicle electronic center or electric control centers. So we're partners with them as well. So these were this as an overview of our hardware competence. And to what kind of is interesting is that what our software partner, which brings all of these hardware manufacturers together, is CodeSys. So we are able to use CodeSys for programming PLCs, to gateways, to HMIs, to getting a simple CAN J1939 I/O module set up in the CodeSys, which I think Curtis is also going to talk about later here. So our use cases, the kind of markets that we currently play in are, as of course, with the cooperation from all our system integrator vendors, hardware vendors, and software partners. We have our use case from a mobile equipment control system integration standpoint, where we've got a couple of wins under our belt. We're able to integrate both on the ag, off-road, on-road, mobile equipment control system integration side. We also have a couple of use cases under our belt from asset management integration. So stuff like cloud-based inventory of an existing industrial equipment that could be easily achieved using a simple cloud instance, and capturing the data from the machine through the sensors on the machine, industrial asset, and sending it back to the cloud, where we can enable some cool stuff like cloud-based inventory, or some stuff like preventive maintenance. And the third use case that we've got a couple of wins under our belt is from the control systems integration on the power systems side of things. So power system type equipment would include hydraulic power units. It would include gen sets, or say, for example, pump skids that do use some sort of an engine-based control or electric control, and it has some sort of an electronic control system on it, which would benefit from the integration to cloud. So that's one of the other markets that we kind of play in. So these were our system use cases. as we're very big on, we're kind of heavier on the value add side of things, and we're not your typical distributor supplier sort of a company, but our main expertise is in value add. So that's why we've got a separate kind of a market segment, so segmentation based on the applications only. So a few of the applications that we've got use cases for, and that are either under deployment or have actively been already been deployed in past. There, one of them is a cloud-connected snow and ice control system. So snow and ice is a pretty huge market in Canada, where where the application use case or value add of the cloud integration includes stuff like features like zone times calculation. So a simple explanation of that would be, say, an owner operator of the snow and ice fleet, or for example, a city or a municipality could benefit from the amount of time it takes to clear a certain route. And historically, that data would be captured year over year to integrate that to finally integrate that to cloud-based machine learning algorithms like deep learning and stuff. So where we could use that historical data to predict the next time it's going to take for that zone time calculation, and also use that data for advanced logistics planning as well. So a couple of other value add use case, because it's all one cloud family, are fleet management and machine diagnostics, which are pretty self-explanatory, but you don't have to send a guy out to the machine to see what's wrong with the machine, but you can remotely dial into the machine and see how the machine's doing, if a hose is burst or if pressure filter is choked or whatever. And then you could bring that information and basically troubleshoot, do some preliminary level of troubleshooting with the machine. The next use case that's actively being developed right now, and we're going to talk about this use case here in our application for today as well, is our cloud-connected variable rate and remote diagnostic systems for agricultural equipment. So this is what Curtis is also going to talk about here later today, but the value add for this cloud integration service is features like as-applied data logging. So farmers or any agriculture equipment could now send the packaged engineered data to the cloud, and the cloud can then either visually represent it or historically data log it for under the as applied type of a data package or data set. And we also have the ability to do something we call the hyperlayered data visualization, which I'll get to here in the later, but we have the ability to segment that data in multiple layers of data and visualize them one at a time to kind of dissect them right into it. So those layers of data, what they are, stay tuned, and we'll just get to them at the end of towards the application side of the presentation. And then, of course, last but not least, we're providing machine diagnostics. So it just adds to the value add of cloud integration. The next use case that's also being researched and developed right now is the application use case for a vac truck, or more specifically, a fleet or rental fleet type of a market. So the advantages of this use case is features like usage-based billing. To kind of get a very brief detail into usage-based billing, so most of the rental fleet market is owner-operator market. So the value add for our cloud-based integration would be around how do you bill your customers based on the actual data from the sensors on the machine. So a simple example like a vac truck or any landscaping equipment, or even your typical construction equipment rental market. So a simple Bobcat, for example, in order for to bill the customers on actual usage data, the data that's being sent from the machine to the cloud has to be very precise, has to be calibrated, and it has to be with a low latency. So that's one of our application features on that type of use case. And then, of course, we build in fleet management that's customized to do that market or that usage type, and then also the machine diagnostics that go with it. So it all comes together as a one fruitful IoT integration that has a very little return on investment. So very quick return on investment, say. And this is another use case application that we did. So I also presented this at the last Tech Talk last year in 2020. This is in partnership with our one of our very good customers, Crowell, and Curtis, who's here, also was involved in this, and it was under his guidance actually. The application features for this is around the custom cloud integration as it applies to the volumetric concrete market. So volumetric concrete mixers are very different from your traditional drum type transit mixers. So a traditional fleet management slash machine diagnostics, or even your remote diagnostics, they are very custom for this type of machine. They're very complicated hydraulic machines that have a lot of moving pieces, a lot of sensors on the machine. So it made sense for as a value add for them to develop a customized cloud-based application that also uses their brand name. And so we launched Prospider 2 years ago, and we're currently on the release 3 of the Prospider. So we're building in features like fleet management, which is specific to volumetric industry. From an owner-operator business models standpoint. And we're also building in scheduling, invoicing, and payments. We're building in, most of these end users would have their own ERP systems on their place. So like Oracle or SAP or any open source ERP system, we have the ability for this cloud instance to integrate to that ERP system also. So that's just a huge value add that a custom cloud based integration or digital transformation can offer our OEMs or our customers. And this is yet another example of a custom cloud-based application. This is a very unique application that we launched earlier this year. It was in partnership with Olds College. We all know COVID has hit everybody very hard, and we're kind of confined to 4 walls of our house. And the same stands for academic institutions. Students can make it to the college. Research cannot be done in real time at the college anymore. Olds College is a premier institution offering plenty of courses in ag-related research. So agronomy, plant sciences, soil, water, plant-based research. This all had to carry on somehow. So we developed the OCRAY, which stands for Olds College Remote Ag Ecosystem. This, what you're seeing right now, is basically an output from our remote ag ecosystem dashboard, where we've got soil, moisture, light, and even the cameras pointing towards a plant that a student can grow in their house or wherever. And we can capture all that data, send it to the cloud, and we can really carry out research remotely. So it's basically a remote lab or a remote research based platform. It's basically an IoT-enabled learning management system. So this is one of the examples of how we can enable custom IoT dashboards that are very specific to that application. I wanted to get into competitive advantages, and I see a couple of questions popping up as well. And the idea was the last tech talk that we did had a couple of questions that were asked to me. So I kind of thought that it would be nice to make them part of the presentation. The questions that I was asked over and over for the last tech talk were, what subsegments of the IoT integration do we cover? And what differentiates us from other IoT service providers or integrators? So I kind of wanted to go over that real quick and just explain what does an IoT integrator really mean. So to answer the first question, what separates us from other IoT service providers, it's kind of important to kind of broadly classify what are the subsegments in IoT industry. So by no means this is a complete list, but if you talk about the main subsets or subsegments in the IoT industry, well, we've got fleet management, we've got remote diagnostics, we've got custom asset management, in a dashboard format or an app or something that's still cloud-based. We've got preventive maintenance, which uses data from remote diagnostics and uses some algorithms to predict the next failure or predict or checks on the machine behavior and then predicts or roughly guesstimates the preventive maintenance schedule that the companies should follow. And then last but not the least, we've got asset tracking, which we all heard over and over. So these are the main subsegments of IoT industry. So to answer the question, what separates us? We've the capability to build all of them into one common platform and then provide it to our customers. So it's not like we're going to implement 5 different dashboards. So you got to go to 5 different screens to get all the information you need. But we've got the ability to build one ecosystem that's dedicated cloud service for your business that allows you to use all these subsegments of IoT industry that as they apply to your use case. So the next question that I was asked over and over was what really differentiates us from other IoT service providers, and what really, how are we different? In order to understand that question, we got to take a step back and kind of understand what are the main, what's the main workflow? How does an IoT integration happen, really? So I've kind of oversimplified IoT integration or IoT-based digital transformation into these 4 steps. So the 4 steps are basically, first, we gotta know what we're talking about. So we gotta understand the machine. We need to find out what would make sense for a cloud platform. What data would make sense to be represented on that cloud platform. So that's where we kind of really wear our mechanical engineer hat, and we kind of get to the nitty-gritty of the actual, what would make sense from a business standpoint on the digital transformation. We obviously don't want to, a simple example I quote here is, say you're in a fleet management business and you want to implement a fleet management dashboard, and all you want to know is if the tire pressure, TPMS, is on your semi vehicles or tractor trailer or reefer or whatever, they're all doing fine, right? So one way of digital transformation for this use case would be to connect the TPMS system to the PLC and get, like, if there are 16 wheels on this vehicle, get 16 data packets sent to the cloud, and on the cloud you can see actual, TPMS or tire pressure monitor or tire pressure real time, and that solves the purpose. But it's not really efficient. What's really efficient is if you send that data to the PLC, but on PLC you've got an additional check or engineer data conversion, which looks for all that tire pressure monitors locally, tire pressure sensors locally, and then only transfers the information to the cloud when needed. So in event your one tire goes flat or loses pressure, at that time you send the data to the cloud. So by just inventing this whole optimization technique, you've kind of narrowed down your bandwidth consumption. You've made your IoT implementation more efficient, reducing the ROI time on your IoT implementation. So that's what we really bring to the table on the first phase or step. The next step or the phase of the IoT implementation is understanding the control system. Of course, the simple way is that you've already got a machine that's out in the field for 20 so years, and in order for that machine to go start talking to the cloud, you gotta gut the whole thing out and rewire the whole thing. That's one way of doing it. But the other way of doing it is you wear the control systems engineer hat, and then you kind of go down to the machine. You get dirty with the machine and find out exactly what's going on. What's the efficient way to retrofit not the future models, but also the models that are already deployed in the machine, and then get that information to the cloud. So why should the machines that are already paid for, they're already working, why should they be left out? So that's really the second step of the digital transformation. The third step, of course, is what's the appropriate connectivity to the cloud? Do you want to use wired? Like if it's an industrial application, why use a 4G or a cellular network when you've got Wi-Fi or wired internet to every site? The other question we answer in this phase, or the other question that needs to be answered in this phase is, do you have cell connectivity? Do you want to use cellular? Do you want to use satellite? Do you want to use lower advanced technologies like a long-range wireless area network, so LoRaWAN, for example? And then last but not the least, which is the major step, is defining the wireframe, the UI, the UX, and walking it through all those development phases to develop a cloud interface that works for you, not a cookie cutter type of cloud interface that's meant for every application, and you got to write your own operator manuals to understand that cloud integration. So that's the fourth step. So jumping back to the questions, what really separates us from all the IoT integrators or service providers? We cover all those four steps that we discussed in the previous slide. So we've got teams in place to just sit down with your business managers and then hand it off to your operators. So we take a project on from a start to finish, and also match it up with a long-term service to manage that product, to evolve that product into a separate business unit eventually. We have successfully implemented IoT solutions using various type of hardware manufacturers and various type of softwares, and convert it into the CodeSys and integrate to the digital to carry out the digital IoT-based digital transformation. Do drop us a note if you want to find out more about how we've used CodeSys IIoT libraries to integrate with the cloud. So your existing CodeSys-based control system is pretty much ready to talk to the cloud. You just drop us a note to find out. So with that, we're just going to jump onto a quick video about our process, and hopefully you guys can hear all the audio as well.
IoT integration is challenging. Solving these challenges require a careful selection of network technologies, hardware components, and user experience UX design that all works together to get you the quick return on your investment. Our goal at TRS Systems is to make it all work together for you. Our IoT process begins with listening. We go the extra mile to understand your machine's control system and create an IoT use case that is customized for your business. Then we engage with your engineering team to design the hardware architecture needed to create an effective telematics solution for your equipment. We also help you select and evaluate the hardware and other system components for seamless implementation of telematics to your new and existing equipment in the field. We realize that the IoT connectivity is a challenge and understand that different use cases need different connectivity solutions. Our team helps implement the best network connectivity to fit your use case. Finally, a smart and intuitive web dashboard is what separates your IoT digital transformation from your competition. Our UI and UX experts work with you through all the steps of the design to launch a cloud dashboard that is customized to your business. At TRS Systems, we simplify the IoT digital transformation journey for you. Get in touch with us today to discuss your IoT use case. TRS Systems.
So that was a brief overview of our process, and with that, I'm going to jump into the actual highlight of the presentation today, which is a project we did not so long ago. It's a project called a manure spreader, and we worked with the McKee Ag Solutions, and Curtis is going to present this portion of the presentation. He's going to talk about control systems and cloud integration associated to this project. Curtis, take it away.
Thanks, Rav. So my name is Curtis Steele. I'm a mechanical engineer by trade, specializing in the fluid power industry pretty much all my career. And I've actually been using CodeSys for about 14 years, specifically in the mobile type applications. But in fact, the application we're going to talk about here shortly with McKee Ag is probably one of the first applications I worked on when I first learned CodeSys 2.3 back some 14 years ago. So my primary job though is the VP of Engineering at Pro International Manufacturing. We also use several CodeSys based devices there as well. And as Rav mentioned before, we manufacture volumetric concrete mixers. Go ahead. So just a brief overview of the hardware that's being used on the spreader, and then I'll get into just some of the more specific components on it after that. But on this current design, they use a Topcon V3 CodeSys based HMI or user interface. The Eaton HFX20 is the main controller, or the main brain for the spreader, and we also have a CodeSys based TRS gateway that is talking to the cloud and sending all our various CAN data to their user interface in the cloud. Okay. So a little bit about how what are the components on these spreaders. So essentially, it's a hydraulic-based system in the McKee solution. There's a tandem hydraulic pump. One pump drives the beaters. What you see here is actually a vertical beater system at the back end that spreads the manure, the product, out the end. And then there's also the hydraulically driven end gate or tailgate, sometimes is how they refer to it, that opens up to allow the product out the back end, and also a hydraulically driven variable speed floor. So that's a pretty typical concept for a manure spreader. Again, hydraulically driven. So what you see here is essentially the main operator interface, or the HMI, that TRS has developed for McKee Ag. And some of the user controls or operator controls that you see here are things like your end gate up, down, beater on, off, that kind of thing. We also have in the system is like a CAN bus based keypad made by Danfoss. It's their HMR series that allows them to have some redundant control. So you can either use the HMI or the Danfoss keypad to control the spreader. Next. So the spreader control screen. So one of the key components, obviously, of this machine, or actually the highest horsepower load type component, is the beater that you see in blue on the back end of the picture here. In this case, it's a horizontal beater system. What the control system is always kind of monitoring or watching for is the torque load on that beater. So we need to control that, because you've got obviously a maximum load that you can put on the drive line, the transmission, the PTOs, all that kind of stuff on this type of equipment. So we actually do a pressure control, which essentially is a torque control in this case, for that beater circuit, so that the operator doesn't have to try and, which is impossible anyways, but try and monitor what that looks like. If they're trying to drive the floor too fast and that is increasing in pressure, the control system's monitoring that and will stop the floor or slow it down accordingly based on the load that you would see on that beater. So the control system has other auto functions too that we've built in. Things like end gate auto, so the operator can hit a button, the end gate goes up and automatically stops. The other feature is this called floor auto, and it kind of works in unison with the end gate auto. So when the end gate goes up, stops automatically based on the pressure, and the floor turns on and starts running. So when the operator gets into the field, he can essentially hit one auto button and the whole machine starts working, and he can concentrate on navigating the field and figuring out what direction he's going in, essentially. Okay, go ahead. So yeah, so basically there's various controls. One of the features that we also have with this particular machine is a feature called constant rate. And what that allows the operator to do is essentially set a amount in tons per acre and a spread width for the actual width that the beater is spreading the material. And the floor is controlled automatically. So essentially, you get into the field, you set all these weights and spread widths are kind of preset before you get there. The operator, all he really has to do is do the auto start function and start driving, and the floor speed is controlled automatically. And this whole constant rate scenario is kind of a segue into the variable rate that we'll talk about here, or Rav will talk about a little bit later, where now you're actually not just controlling floor speed, but we can control things like beater speed and like if you're, say, driving around a water hole or something like that, it can control that spread width and obviously change the rate variably based on what the end user farmer wants to see as far as the fertilizer application in their field. Next. So a few other features on the screen is alarms and diagnostics. So if you've got a service guy at a, if you had a big feedlot or multiple machines like this, they're going to want to know how to troubleshoot things or how to monitor, what is the driver doing? Is he, controlling the machine properly? Is there other training required? Things like that. So with the alarm manager built in, they can go back and see, has it hit a high pressure beater alarm? Is there a high temperature alarm on the hydraulic system? Do they, maybe that would be an indication that maybe the oil cooler is starting to plug up with straw or, things like that. So they need some maintenance, right? Involvement there. Other things like, coil disconnects and we're monitoring like even the feedback or the coil currents to each of the hydraulic valves. So in a sense, you've got on this HMI or a tool that, the maintenance guy can go up to this machine without a multimeter and start troubleshooting it right from the display. Okay. So these are just some real brief code snippets. I just wanted to highlight, obviously the, CodeSys is a 61131 based programming software. And obviously the beauty of that, if you're new to CodeSys, is you can program in any language that you feel comfortable with. For me personally, I like structured text and CFC. That's kind of my go-tos, but even if you're used to ladder logic and all these other languages, it's just so simple to use and to build your applications quickly. And then at the bottom there, you can see the CAN bus managers, and I'll talk about that here in a minute. But again, implementation time is a key kind of factor with some of the stuff, and CodeSys is certainly a nice tool to use to get your applications done quickly. Okay. So another component, for those of us who've been doing this a long time, the function blocks and the libraries that we can build over the years. Again, people that are new to CodeSys, this is so important to have, not reinventing your code and being able to save it and reuse it over multiple applications. It saves so much time. And I mean, this is just an example, but you can see there's multiple function blocks in there. But again, a lot of these get reused over the years for sure. So in this particular application, as I said before, we're integrating a Danfoss HMR rotary encoder. I just briefly wanted to highlight again how simple it is with the the J1939 manager and the libraries that are built into CodeSys to integrate any kind of piece of hardware. So in this case, the Danfoss HMR uses a standard J1939 message using the auxiliary IO1 and 2 messaging. So all you really got to do is enter in the PGN and a source address, and you can start monitoring button clicks. So again, really, really nice feature of CodeSys. And then the second piece is the CANopen side of the bus management. We use CANopen to talk to the HMI in this case, and also the TRS CodeSys-based gateway. And again, just the integration and the ease of it using EDS files, and essentially just add the device, add the EDS file, and start mapping variables. It's very, very quick and seamless. And just again, just a quick takeaway with CodeSys. Like I say, if you can dream it, you can build it. It's you don't have to be a software engineer to do it. Although now with the object-oriented programming capability with CodeSys 3.5, the software engineers, I'm sure, are happy. And it's a great tool. Thanks, Ralph. I think yeah.
Okay, well, thanks, Curtis. So just on that note, I'm gonna translate. So thank you, Curtis, for explaining the application. Really appreciate it. So as Curtis mentioned, when the data, we've got our gateway running CodeSys 3.5 as well. So the beauty of that is all you got to do to integrate to another CodeSys-based PLC is you just got to bring in the EDS file for the gateway to your device and start talking to the cloud. Now, that's what we're doing here. but I just wanted to take an opportunity to also kind of leverage what are the other advantages. So yeah, the data makes it to the cloud. So we'll kind of go on to what happens, or what have we done with this project so far. So the first step that Curtis mentioned, and I think there was a question about that as well on the chat, in the Q&A section. So the first step of any cloud integration is wireframing. So what you see here on the right-hand side is the wireframe that we did about a year and a half ago on how this product is going to look like once it's launched. So our customers can have an exact idea of what are they going to get. We really follow the philosophy of what you see is what you get. So with this the idea was, this we're going to integrate this telematics gateway, the EMERCLOUD 4G gateway, and the telematics data is going to flow from the gateway to the cloud, and the cloud and also the gateway is going to provide GPS signal back to the truck or the truck control system over CAN bus, and so on and so forth. So this was the wireframe stage. And then when we implemented it to the real, the cloud-based product, this is what the cloud-based product looks like. So this here, what you're looking at is the dashboard side of things. So the dashboard, on the dashboard, what you see is, how many devices are there, how many users are there, how many active sessions are existing. And on the next slide, we're going to see what this product looks like. So really, it's exact, wireframe-wise, the skeleton of this exact implementation is very close to what we had proposed a year and a half ago. So, really kind of simplifying the IoT integration is the idea here. So this is currently deployed. It's working. We've got a couple of trucks out that are actively using it. Where are we going to take it from here? So that's where I really wanted to go into this a little bit of sneak peek and kind of explain what are we getting data to the cloud. That's fine. That's a very simple cloud integration. But what really it leverages us? Where's the value add? So that's what I'm going to go into a little bit of a sneak peek here. So what we're seeing here is the data goes to the cloud and goes to the dashboard, and you're looking at it. You get the data logging, you get remote troubleshooting, you can see the alarm numbers that pop up on the machine. And yes, all the DM1, DM2 messages can also be composed in the alarm and sent to the cloud as well. For the next iteration, or V2.0, we're going to really focus in on what kind of fancy stuff we could do with the maps integration. So all we've got is the GPS latitude, longitude, and speed data coming up to the dashboard, and we're really going to focus in on that. So this is what it kind of looks like right now, where currently the data set that we have, we've got a field, we've got a truck on the field, and we can see the as applied data. So, the spot where the manure is already spread on the field, and that's pretty much it. The advantages, we can maybe use it to integrate. If there are more than one trucks or two trucks on the field, they can avoid overlap or overspraying and all that kind of stuff. And yeah, the data is handy. It comes in for future purposes and so on and so forth. But for the next iteration, we're going to split that data set into multi-layered data. And that's what I meant by a hyper-layered data visualization. So we're going to split that data into the drainage data. So we can find out the users or the farmers, producers, the owners of the equipment can get the ability to enter the drainage data in a GeoJSON format or any of the other leading industry formats to the cloud. And the cloud understands how the drainage on the natural drainage on the farm works based on its topography and elevations. We're also going to provide the ability to get the vegetation data into it. So different crops, different type of fields need different amounts of manure, different types of manure. So in order to kind of segregate that data set, we're going to provide the ability to enter the vegetation data and also relate that vegetation data to the amount of manure it needs over the year. So it can predict how much manure should actually go on that section of the field. And then finally, we're going to provide a user adjustment data, which is a very, very simple implementation of a geofencing. So we're going to use a lasso type tool where the farmer on an iPad has the ability to draw the boundaries and associate a rate to that boundary, or we can just import the GeoJSON from any existing boundary conditions or any existing database platform out there. And then last but not the least, we've got the as applied data from the previous years, and we've got the ability to kind of analyze that data on what effect did it have on the crop for that season. What we're going to do is the cloud's going to perform the math to calculate the variable rate data. And that variable rate data would be a combination of all these 4 data sets and calculated as part of that process. And that variable rate data gets sent back to the cloud, and then it makes its way back to the machine. So the operator is just going to go drive on the field and do what it's doing, do what he's doing anyways. And the rate adjustment is going to happen automatically based on the cloud integration. So that's what kind of the advantage of having a custom cloud platform do all your remote IoT integration. So this was all made possible on our software as a service SaaS platform called ImmerCloud. Do visit us and drop us a note at ImmerCloud.com to find out more about this, these type of integrations. ImmerCloud, is a quick way to integrate your control system to the cloud. If you just want to try it out, test it out before launching your full-blown cloud or digital transformation journey, it provides you with a safe, secure, and quick IoT dashboard. And because all the database and the background work is already done, we have the ability to launch it quickly for you. I just wanted to kind of go over what is it that we offer. We offer our services as 2 major type of subsections. So the first one is any ImmerCloud-based IoT dashboard, which is ready to go cloud solution. We kind of market that as. It's still customizable, but because the background, the legwork is already done, the architecture, the servers are already set up, it provides us to build up a quick front end and launch it for your business to get a quick, simple dashboard for your application. The second type of service we provide is a dedicated cloud-based product, which, one example that of the dedicated cloud-based product is Prospider. We launched the Prospider SaaS about 2.5 years ago now, and this is a very custom cloud-based application that has evolved into it's got fleet management, remote diagnostics, ERP integration, and we're even trying bidirectional communication, and there's plenty of cool stuff. And the best part is it's associated to the brand already, and so people know that this is backed by the OEM that makes the machine. So that's what really separates a dedicated cloud-based product offering. And then OCRAY, which you guys have seen, this the Old College Remote Ag Ecosystem, which is also a Smart Ag Cloud, is one of the other examples of a dedicated cloud-based product. So with that, and last but not the least, all these products, they're seamless integratable with CodeSys IIoT libraries. So if you have it in a CodeSys enabled control system, we're golden. So I'm just gonna sum it up with that. And if you wish to engage with us, please feel free to drop us a note at info@trs-systems.com. That was my time. Thank you very much, Chris, and thank you, Curtis, for co-hosting this with me. I really appreciate the time.